Okay, so let's start inequations. So first of all, this is inequations for linear inequations. Okay, so first of all, we'll start with linear inequations. Okay, so suppose I tell you that x is greater than y, and I ask you what all you can predict for these values x plus a, whether it is greater than or less than y plus a. Same thing, x minus a, so I'm subtracting a constant from the same from the variables, a multiplied by x and a divided by the variables. Now for the first two, the inequality sign will be the same for the parent inequality, but for these two you will have a range of solutions, which is the sign of the inequality will depend on the the constant terms or the sign of the constant terms. If a is positive, then ax will be greater than ay, but if a is negative, in that case ax will be less than ay, and the same thing will hold true for this also. Let me take an example to say. So suppose 3 is greater than 2, it is given. If it is given that 3 is greater than 2, now let me multiply this by 2, so this becomes 6 and this becomes 4. When I multiplied by 2, 6 is still greater than 4. But what if I multiply the number by minus 2? In that case, this will be minus 6 and minus 4. If you pay attention, minus 4 is greater than minus 6. Okay, minus 4 is greater than minus 6. In that case, minus 6 will be less than minus 4. In other words, the inequality sign will always reverse when you are multiplying or dividing by a negative number. So the negative number is important. Okay. Now let's go to the next property of inequalities, which is inequations with modulus. Okay. We all know what modulus is. Modulus is the absolute value of any number. So mod of x is equals to minus x for x less than 0 and x for x greater than equals to 0. What this basically means is, some of the students find this a little difficult, but let me explain this, how this is minus x. The absolute value of any number will be positive, but the variable inside the absolute operator can be a negative one also. That is what is depicted over there. Suppose I have a minus 3. So this is minus of minus 3 according to the first line. That in fact gives me plus 3. And if it is a modulus or mod of 3, it will be 3 itself. So we don't really need to worry too much, but then we have to appreciate that we need to check for both the branches, for a negative branch and for a positive branch. Why is it important? Because just by looking at the variable, we cannot predict what the nature of the variable is. So we have to actually take both the cases and see which one fits the inequality bill. Let's do an example. Okay, so say I have an equation mod of x is greater than 5. So I'll do the check for both the minus 5 and plus 5. Take any number beyond the plus 5. Say this number, say let's take the number as 6. Does this satisfy? Yes. Alternatively, put a cross and a tick. So the answer will be in this range. Okay. So this is going to be x will be in the range minus 5 to 5. Let's do this once again for another number. So let's say mod of x this time is less than 5. The same idea remains. Minus 5 plus 5. Take any number beyond the positive 5 and check. So if I check for this number, suppose this is 6. 6 is less than 5. No. So this is not acceptable. Alternatively, tick and cross. So the range will be, the possible values of x will be found in this range, which is less than 5, x will be between -5 and 5. Okay, I hope that makes sense. Now let's do a different one, which is let's say x minus 3 mod of x minus 3 is less than 5. Now the same thing, this is -5, this is 5, and I have no idea. First of all, I'll ignore the -3 at this point, but any number beyond 5, okay, any number beyond 5, let's take a number to be 6. Is that less than 5? Definitely not. So this range is not allowed. This will be allowed, this will not be allowed. So this is the range. In other words, the answer to this one will be x minus 3 less than 5 greater than -5. But remember, we will always be asked to calculate for x and not x minus 3. So all I need to do is add 3 to both the side. When I add 3, this becomes 8 and this becomes -2. So the range for x for this inequality, x minus 3 less than 5, is this thing. Okay, practice couple of more and you'll get there. Let's go to the next idea, which is inequalities with quadratics. Okay, let's say we have a quadratic x square that is greater than 25. Now obviously x is greater than plus or -5 in this case. We will transpose the square to the RHS, make it a square root, and then so on and so forth. Let's jot the critical points -5 and 5 on the number line. Take any point beyond 5. Take 6. 6 ka square is 36. Is that greater than 25? Yes. That means this range is positive and alternatively negative positive. Or you can simply say every time the right hand side will be positive, and alternately you can decide the scheme. So because we were supposed to find out the range in which x square is positive, the range in which x square is positive are these ranges. So the answer to this question would be x less than -5 union x greater than 5. You can also, instead of this union sign, you can also use the word or. So x less than -5 or x greater than 5. Both of them are acceptable, whichever is given to you. Okay. Now let's try one more. So this time around, let's say we have the quadratic expression as x square minus x minus 6, that is less than 0. Give me two numbers, the product of which is -6 and the sum of which is -1. Those two numbers will be x minus 3 and x plus 2. Factorization will help me with the critical points. So I will get a -2 and a +3 as the critical point. Plus minus plus. We are supposed to find out the range in which this expression is less than 0. This is that range. So between -2 and 3, x will lie. This method, if you must, is called wavy curve method. Okay, you don't really need to know everything, but then that is what it is. What about a higher inequality? So suppose an inequality is given, a higher order inequality is given, such that you factorize to get a number like x minus 2, x minus 5, x minus 7, x minus 10, and x minus 15. There is a expression which, when factorized, give these many, this thing, and the expression has to be greater than 0. So nothing different, we'll do the same idea which we have been doing so far. So 2, 5, 7 will plot the critical points. Positive, negative, positive, positive, negative, positive, negative. Okay. If you have to draw the graph will be something like this. Okay, the graph will be something like this. Okay, freehand I'm drawing this thing. And all the positive ranges are what the answers are for our purposes. So this is the one, this is the one, and this is the one. When we write them, we will obviously write it like x lies between 2 to 5 union, x lies between 7 to 10 union, x lies, x is beyond or at this point greater than 15. Okay, so one part will be this one and the other part will be this one. So higher order inequality will also be solved through the same wavy curved method. Okay, that's it.